8.2, we're going to work on multiplying polynomials. So we've done adding and subtracting, and now we're going to multiply. And our vocabulary is, again, polynomial and binomial, which we already had in the first section. So we're going to go through a number of different strategies for multiplying polynomials. You should experiment with them and discover which one works the best for you. Okay, so I'm going to show a lot of different ways to go about it, but in the end, what's most important is the methodology that works the best for you. So you can see sort of what happens here when you're multiplying polynomials. We've got two x's here, so for representing the 2x, plus 3, so here's 1, 2, 3. And if I'm multiplying it times x, that's what we have here. This is sort of graphically what it's like. So it's going to be x times x, which is x squared, x times x, which is x squared, x times 1, x times 1, and x times 1. So you'll see I have 2x squareds, and I have 3 x's. Okay, so that's sort of how it works. Also, we could use the distributive property, x times 2x, and x times 3, right, which becomes this and this, which also leaves us with 2x squared plus 3. So this is more the way that I personally learned how to do this. So that's the way I'm going to do this first problem. I'm multiplying by a monomial. So I have z squared times 4z to the 4th. So I multiply the coefficients. 1 times 4 is 4. And then I multiply z squared times z to the 4th. That's z to the 6th. And then we'll get plus z to the 5th minus 11z to the 4th minus 6z squared. Okay, so I just took z squared and I multiplied it times each individual term in my 4-term polynomial. Okay, so we can do this using a table, which is very similar to this example here. And if I wanted to go ahead and create a table, I'm going to take these terms, 5x and negative 8. Oh, I'm sorry, the book is asking me to go ahead and write things as subtraction. It's not really necessary. As long as you remember what I've already told you, that when you're talking about terms, the sign in front of it is part of the term, you'll see that it will work out exactly the same. So you really don't have to do this step of rewriting it as addition. But then when I make the table, I'm going to take the 5x and I'm going to take the negative 8. And I went across horizontally. And then vertically, I'm going to do 2x and the negative 5. And then what I do is I just multiply the intersecting items. So 5x times 2x is 10x squared. Negative 8 times 2x is negative 16x. Negative 5 times 5x is negative 25x. And negative 5 times negative 8 is positive 40. And you can see I have like terms here diagonally across from each other, and I'm going to combine them as I bring things out. So I'll have 10x squared, and I'll have negative 16 and negative 25. That's negative 41x plus 40. So this is how you can set it up using a table. You can do this for polynomials of any size. And this happened to be doing binomials. Okay, we can multiply them vertically as well. So more like you initially probably learned multiplying multiple digit numbers. You did them vertically. So I'm going to arrange them here. And as you would there, I'm going to take this negative 6 and I'm going to multiply it times each term. So remember, I've got 8n, I've got negative 5, I've got negative 6, and 3n. So negative 6 times negative 5 is 30, positive 30. Negative 6 times 8n is negative 48n. And then 3n times negative 5, that's going to be negative 15n. And of course, just like you would have kept vertical alignment between ones and tens and hundreds, I'm doing that with the different terms. So I've got like terms in vertical columns. Lastly, I'll have 3n times 8n. That's going to be 24n squared. And then I add everything together. So here's 24n squared. I have negative 8 and negative 15. That's going to be negative 63n plus 30. Okay, and the way that I learned personally was multiplying horizontally. And basically I need to take each of the three terms that's in here, in the first set of parentheses, and multiply them times each term in the second set of parentheses. In this case, it's a trinomial times a binomial. So I'll start with the 6z squared. 6z squared times 9z is going to be 54z cubed. 6z squared times negative 5 is going to be negative 30z squared. And now I'm going to move on to the z. Z times 9z is 9z squared. And z times negative 5 is negative 5z. Now I move on to the negative 1. Negative 1 times 9z is minus 9z. And negative 1 times negative 5 is plus 5. And now that I'm done, I want to combine like terms. So I have like terms here, and I have like terms here, and I need to combine them. So I'll have 54z cubed. I'll have negative 30 plus 9, that's minus 21z squared. I have negative 5 minus 9, that's negative 14z plus 5. And this is my product. Okay, you're familiar with FOIL. FOIL is the distributive property again, but it's the distributive property when you're multiplying two binomials. They would have to be binomials in order to use FOIL, because you have firsts, which are multiplying these together, and then outsides, multiplying those together, insides, and lasts. And that only happens to have 4 results when you're multiplying two things times two things. Okay, so if I go ahead and do this, I'll have 4m times 2m, that's 8m squared. And then 4m times 7 is 28m. 9m times 2m is 18m. And 9 times 7 is 63. Again, I'm going to combine like terms. 8m squared plus, we're going to have 46m plus 63. Okay, and I want you to point out, because right now we're multiplying, and in later sections in this chapter, we're going to be factoring, which is essentially unmultiplying. And what I want you to remember is that when we look at a quadratic function and we look at the first and last term, we can kind of figure out what possible items were the firsts and the lasts, right? So we know it was two things that multiplied together made 63, right? And then what you're doing when you're factoring is you're testing the different possibilities to find out which outsides and insides make this number, the 46. Okay, so just remember that this FOIL has a deep relationship to what we're going to be doing later when we're factoring. Here's a problem about a park. So we're designing a rectangular skateboard park on a lot that's on the corner of a city block. And we have a certain amount of space. So you can see the total space we have is 45 feet by 33 feet. But we want to have the park and a walkway around it. So we want to leave x, this unknown amount of feet, for the width of the sidewalk. Okay, so when we want to write a polynomial that represents the area of the skate park, I want to start with area, the idea of area of a rectangle. Area is equal to length times width. Well, let's look at our length. When we look at our length, I've got a total of 45 feet, but then we have to take out this x, right? Because I'm literally looking for the dimensions of the green area, and the sidewalk gets subtracted out of that. So I'm going to have L minus X, right? Actually, I know what L is. I know it's 45 minus X. And when we talk about the width, it's 33 minus X. Same reason I'm taking out for the sidewalk. And if I multiply this all out, I know I'm going to have 45 times 33, which is 1485. So I'm going to have 1485. And then I'm going to have 45 times negative x, that's negative 45x. And 33 times negative x, that's 33, negative 33x. So I'm going to have minus 78x. And then negative x times negative x is plus x squared. And that's my area. Of course, if I was going to order my polynomial correctly, the 1485 and the x squared would switch places, and it would look like x squared minus 78x plus 1485. Okay? If we're going to figure out the area of the park, if the walkway is 3 feet wide, I need to substitute 3 in for x. So I'll have x squared is 9. 3 times 3 is 9. Minus 78 times 3. 78 times 3 is 234. Plus 1485. Okay, so if we go back to it, here's my 234. If I make that negative, and then I add the 9, and I add 1485, I see that I get 1,260 square feet for my area. So it's 1,260. Okay, and that's working with a very simple overview of multiplying polynomials.